One topic that we kind of gloss over during Calc 1 is inverse trig functions, and especially their derivatives and integrals. But they are definitely important and will show up especially on a Calc 2 test, and in terms of further math, a lot more than they will in the AB exam. So we want to touch back on them. And here they are, all 6 inverse trig functions that you may have to know their derivatives. But basically, you only need to know half of them. Arcsine, arctangent, and arcsecant. Because the difference between arcsine and arccosine is that the co-function is just negative. Same with tangent to cotangent. The arctangent is positive, the arccotangent is negative. Secant to cosecant, again, secant's positive, arccosecant is negative. So if you just can remember those 3, especially when we get to integrals, that'll be very important to recognize the pattern of them, as in sine has the square root on the bottom, tangent does not have a square root on the bottom, and secant has this extra absolute value of x on the bottom as well. That's all you really need to know if you choose to memorize them, and even that isn't completely necessary. We'll get to that in one moment. But here's how you're going to use these. So it's not going to be just arcsine of x. That would just be way too nice and easy for us now, wouldn't it? So arcsine of 2x, you're going to use the formula that you know, 1 over 1 minus, but it's not x squared now, it's 2x squared. But it's a chain rule, because you have something on the inside. So you better multiply by derivative of the inside and simplify. So 2 over, and that denominator now is 1 minus 4x squared under the radical. Okay, it works the same for our tangent here. Use the formula. This is the one tangent without a square root, so 1 over 1 plus 3x squared. What did I forget already? I forgot to multiply by the chain, derivative of the inside, so I should get 3 over 1 plus 9x squared. Arcsecant of e to the 2x. Oh, this is going to be fun. So arcsecant is 1 over the absolute value of e to the 2x, square root of e to the 2x, that whole thing is squared, minus 1. Again, I just forgot it. Very common. You did the whole formula, you still need to remember multiply by derivative of the inside. The derivative of the inside would be itself, and it has its own inside, so times 2. So now times, simplify this, I get 2e to the 2x up top. The denominator, absolute value of e to the 2x. Well, e to the 2x is always positive to begin with. So e to the 2x can even come out of the absolute value. Then I still have the square root of power to a power, means you multiply them, so I should have e to the 4x minus 1 under the radical, and I can simplify that because I have e to the 2x's on top and bottom, and I should get this as my simplified result. So that's all, well and good if you know the formulas and if you have those formulas memorized. What if you forget? Well, there's actually a way that you can solve these problems without knowing the formula. Here's how. So imagine you have the derivative of arcsine of 2x. So really that means we have a function y equals the inverse sine of 2x. What if I rewrite that so I don't have to have the arcsine, the inverse sine? What if I took the sine of both sides? The sine and the arcsine would cancel out, and you just have 2x left. So all I did here is I just took sine of both sides, so that sine and arcsine would go away. Well, the reason I do that is I know how to take a derivative when I don't have y by itself. It's implicit differentiation. The derivative of sine of y would be cosine of y, but it's a derivative of y, so I need to tack on dy dx. That would equal 2. Okay, cool. I can now get dy dx by itself. It would be 2 divided by cosine of y. Well, interesting. Well, we found our answer on the last slide. It was 2 on top, the square root of 1 minus 4x squared on the bottom. Well, we can already see those are kind of similar. But I have an answer that's in terms of y down here, but in terms of x's up there. How can I get it back? Because it's got to be in terms of x, because we have a problem in terms of x. Well, Here's how you're going to do it. Good old trig, we can draw ourselves a triangle. The very beginning, we had, or not at the very beginning, I guess, we had this equation right here. Sine of y equals 2x. Y is an angle. So I'm going to pick one of the angles to be called y. Sine of that angle, meaning opposite over hypotenuse, is 2x. So the opposite, I'll call 2x. The hypotenuse will be 1. Opposite over hypotenuse. I can use that. I know two sides. I can find the third side just by saying, a squared plus b squared equals c squared. So this becomes 4x squared. That's 1. We're trying to find a. So a would equal, it's 1 minus 4x squared. That's what a squared is. So a is the square root of that. 1 minus 4x squared. 1 minus 4x squared. They want to know what cosine of y is. And that's why we found this extra side. Cosine is adjacent over hypotenuse. So that means this denominator is 1 minus 4x squared. Numerator was just 2, and hey, look at that. We have an answer in terms of x, and it matches completely with what we had at the beginning. So is it a little more work than just memorizing the formula? Oh yeah, absolutely. But if you forget it, you have a brain fart, you have a chance to go and make it up using implicit differentiation. Here's another one. I encourage you to try this one first. See if you can get what the answer was on the previous slide, which was 3 over 1 plus 9x squared, following the same steps we just did on the last slide. All right, did you get it? We first say that y equals arctan, or I can call it tan inverse of 3x. So I need to then rewrite that by taking tangent of both sides. Tangent of y is equal to 3x. When I take that derivative, I get secant squared of y dy dx is equal to 3. So that means dy dx would be 3 over secant squared of y. If you got stuck, I'm guessing this is probably where you did. I would have rewritten this, because I don't like secant, as 3 times cosine squared of y. Bring secant to the top and call it a cosine. And now I'm in the same spot, though, as I have a y. I don't want y. I need it to be in terms of x. So here's my angle y. This time it's tangent of y equals 3x. So opposite over adjacent has to equal 3x. And now I can find my hypotenuse. A squared plus b squared equals c squared. So 1 plus 9x squared should be your hypotenuse. We now want to know what cosine squared. We'll really just start with cosine of y. Cosine of y would be 1 over that square root of 1 plus 9x squared. That's what cosine is, but we want cosine squared of that value. Well, squared, all that's going to do is cancel out your square root. So that means I have the 3, and I have 1 over, or not the square root anymore, 1 over 1 plus 9x squared. And I'm just going to bring the 3 up to the top. 3 over 1 plus 9x squared. Guess what? That's what we had. Perfect. Now you can use it with implicit differentiation as well to find your inverse trig derivatives.